Greetings, everybody. On July 31st of 2023, Math 505 evaluated this awesome looking integral using contour integration. And I'm just going to add a couple points to that. I'm actually going to introduce a more organized way for finding the arguments of z minus I and z plus I over the paths psi1 and psi2. And I'm going to do that by writing parametric equations for these paths, finding the expression for z minus I, z plus I, and then evaluating the argument by looking at the uh, signs of the real and imaginary parts over these intervals, which are assumed for the argument of z minus I and z plus I. And since psi1 and psi2 are actually line segments, a routine way for writing parametric equations for those is z equal to 1 minus t times the initial point, the point at which they start, plus t times the final point, where t runs from uh, 0 to 1. So for example, for psi1, the initial point is delta plus I times cap r, and the final point is delta plus I. So for psi1, we can write the parametric equation as 1 minus t times delta plus I times r plus t times delta plus I. And if you expand these out and simplify, the real part of z is delta. That's obvious since the real part does not change. And for the imaginary part, we get r times 1 minus t plus t. Now I can add an I to this or subtract an I from this to get the expressions for z minus I and z plus I. For z minus I, we get delta plus I times r times 1 minus t plus t minus 1. And as delta approaches 0 from above, and note that the interval for argument of z minus I is between pi half to 5 pi halves. And here we notice that the real part of z minus I, which is delta, is positive. The imaginary part is also positive. Since t is less than 1, this is a positive quantity, and r is assumed to be large. So all in all, the imaginary part of z minus I is also positive. So the real part is positive and it is tiny. The imaginary part is also positive. So we are very close to the right of the vertical axis or the imaginary axis. And since the interval is from pi by 2 to 5 pi by 2, so at this point it's pi by 2 on the imaginary axis. And when we rotate counterclockwise and end up here, the argument is 5 pi by 2. So the argument of z minus I for the path psi1 is 5 pi by 2. And now if we find the expression for z plus I, we get something similar, delta plus I times r times 1 minus t plus t plus 1. Again, both the real part and the imaginary parts are positive. But now the thing which is different is the interval. We are at pretty much the same point as we ended up in the case of z minus I, but now the interval is from negative pi by 2 to 3 pi by 2. So as we start on the negative imaginary axis and we go counterclockwise, after half a rotation, we reach that point. So the argument is just pi by 2. So the argument of z plus I for path psi 1 is pi by 2. We can do a similar thing for path psi 2. On psi 2, the initial point is negative delta plus I, and the final point is negative delta plus I times R. So for psi 2, we can write the parametric equation as 1 minus t times the initial point, which is negative delta plus I, plus t times the final point, which is negative delta plus I times R, where again t goes from 0 to 1. After simplifying, we know that the real part is just negative delta, and for the imaginary part we get 1 minus t from here and t times R from the second term. And now from this we can find z minus I and z plus I, same as we did before for psi 1. For z minus I, we get negative delta plus I times 1 minus t plus t r minus 1, which simplifies to negative delta plus I times t times r minus 1. So the real part of z minus I is negative, and the imaginary part, which is t times r minus 1, that is positive. So a real negative tiny part and a positive imaginary part. So we are somewhere here. Tiny real part, but negative, and some positive imaginary part. And the argument of z minus I is between pi by 2 and 5 pi by 2. So when we start from the positive imaginary axis, we are at pi by 2. So argument of z minus I is pi by 2. And what do we get for z plus I? If I just change that negative I to positive I, this negative one also turns into positive 1. So the real part of z plus I is the same negative delta, and the imaginary part is still positive, actually more positive. So we are at the same point, but now the interval has changed to negative pi by 2 to 3 pi by 2. So as we start on the negative imaginary axis and we reach that point, we get the argument of z plus I as pi by 2. So I think this method is maybe not easier, maybe not quicker, especially for those who have like good imaginations. And Math of 505 also explains it well, but I think this is kind of more organized and less error prone, at least for me, and I just like to share that with you. Thank you so much, and that's a good place to stop.